my dear students, welcome back to the session. Now let's begin the third chapter, that is memory management. Previously we have completed introduction to the operating system and process management. In the process management, various topics we have covered. Now let's move on to the next chapter, is memory management. Okay. From memory management, so what are the topics which we are going to study? So let's look at here. The first we will see the basics of the memory. Basics understanding of a memory part. Means how to visualize the memory. How we can understand of the main memory. So memory here consider about RAM, main memory. So the basic part we will understand, followed by memory management techniques. Memory management techniques. Means what this memory management techniques is talking about. We are particularly concerned of the multi-programming environment, that is several processes we wanted to keep into main memory at the same time. In order to accommodate the several processes into main memory, so memory need to be partitioned, memory need to be divided into parts. So what are the various approaches available to do this partition? So we'll see the various memory management techniques. Followed by, so virtual memory concept we will observe. Virtual memory concept. See what is this virtual memory is talking about. You are familiar with this, operating system. Like you see, our main memories are generally size, in terms of size if you see smaller in comparison to hard disk. Like RAM sizes would be in terms of, you take like personal computers, 4 GB or 8 GB or 16 GB RAMs are there. When you compare to a hard disk in terms of 500 GB, 1 terabyte, even 2 terabyte, compared to that, very small. So our programs or applications generally we are keeping into secondary memory. According to Von architecture, any program or application need to be executed, that has to be brought into main memory. If a bigger size application is there, how we can run in a smaller memory? So let's say especially if you talk about games, so particular game application, if you take some of them in terms of 4 GB, even 6 GB, 8 GB applications are there, that still we could able to manage with the 4 GB of RAM. Getting? So that means what? Computer is allowing you to run larger programs into smaller size memory. How this can be achieved? Here we can understand the beauty of the operating system. Memory management is a topic. It is very important and crucial topic from the operating system, and also in application point of view, if we see this numerous applications are there. Applications means you understand how beautifully it is creating an environment to running of a large program into small memory, also supporting more number of processes. That means so degree of multi-programming is more. How these all the things can be achieved, we are going to understand in our sessions. First we'll focus in the basics part, then the various partition mechanisms, followed by we'll understand the virtual memory concepts, which available, virtual memory concept available most of the contemporary operating system, including Windows, Linux, your mobile operating system, most of them supporting. So that we need to understand very, very clearly. Chalo. So basics of memory part we will understand. Here our major focus goes on taking into consideration what? Multi-programmed operating system. Multi-programmed operating system, nothing but several processes we need to keep it. So what is the uniprogramming? What is uniprogramming? Already we know, means only one program we intended to compute, so that need to be loaded into main memory, execute, complete, then again another program need to be loaded. Means we don't have a provision to keep more programs, only one program can be kept into main memory at any moment of time. That's what uniprogramming. So what is the functionality of the memory manager? What is the functionality of the memory manager? So memory manager, please understand, here we are talking about what? Multi-programming environment. First look the functionality. The part of the operating system that manages the memory hierarchy is usually called as memory manager. Memory hierarchy, here you understand memory hierarchy majorly. Hierarchy nothing but levels by level. So main memory, that is RAM, and secondary memory, see, operating system also will interact the secondary memories. Means our program initially stored in secondary memory. The programs are loaded from secondary memory to main memory, and whenever required, sometime we can send back to main secondary memory. There again we can bring back to main memory. This swap in, swap out we call. The swap in, swap out functions are done by the operating system only. Means operating system involved. So not only one memory, it will be two memories, like that we call memory hierarchy. Look, the job of the memory manager is to keep track of which part of memory are in use and which part of the memory is not in use. What this line says? Our major focus on multi-programming environment, right? So multiple processes we wanted to keep. When you keep several processes in a main memory, some of them will complete, some of them we can suspend into secondary memory, correct? Means when they complete, they leave, we have to remove those programs, and so the memory get vacated. The partitions are get free. Now operating system must ensure how many partitions are there, how many partitions already in use, and what are the unused partitions are there. It has to keep track. So this free space management we call. So this should also done by the memory manager. Getting my point? So memory manager is a module of the operating system, like a process manager, device manager, file manager. So there are various modules are there in operating system, and each module will do some functionality for some functions or services to the users. Process manager we have observed, right? Process manager will create a processes, it will schedule and provides environment for communicating the processes, right or no? That's a process manager responsibility. If I talk about a file manager, the responsibility creating the file and manipulation of the files will done. Like memory manager, here when a user programs comes, you have to allocate the space to that. When you load the programs into memory, then you have to keep track of all the partitions of the memory. This should be done by the memory manager, right? So look at the next point. Allocate the memory to a process, as I mentioned, when they need it, and deallocate when they are done. When they are done, nothing but completed. Allocate the memory to user process when they are required. Load them, execute. Once execution over, you can leave them, is free of the memory. So to manage swapping between main memory and a disk when main memory is too small to hold all processes. Yes. So we need to operating system should manage the swapping. What is swapping? When it is necessary to swap out the process, we have to, some process need to be swapped out from main memory to secondary memory. Means whenever you feel this memory is not sufficient to accommodate that, so you have to swap them. So later you can bring back to main memory. The swapping, swap out done by the operating system, we call swapping. Swapping, there are two operations, swap in, swap out. Getting swap out, nothing but sending a process image from main memory to secondary memory. Swap in, nothing but taking the program from secondary memory to loading to main memory. This is what swap in. I hope you understand. This is operations are done by the operating system only. Getting? Look this. First of all, I want to show about uniprogramming, also known to be monoprogram. Monoprogram is the simplest possible memory management scheme is to run just one program at a time. Just one program at a time, nothing but one program is loaded into main memory, that is executed and terminated. Again another program you have to load it. If you see the structure here, see the structure, means this is the entire memory which you have to visualize, basically partitioned into two parts. Some part operating system will be the remaining portion for user programs, where you can keep only one program. Naturally, most of the architecture operating system will reside the lower address side, nothing but see, address started 0, 1, 2, 3 like this, the largest address. Lower part of the memory occupied by the operating system, remaining portion for what? User programs. Getting? So some may be like, operating system in a ROM and remaining area is what? User area. This is what 0 to high only. So reverse, sometime operating system will be higher address side, and here so it can be like here in this case you can see operating system is RAM, lower address side user program, some device drivers also mentioned stored in the ROM. So this will vary from architecture to architecture. Just I want to show you that if I take the uniprogramming environment, the structure would be like this. So let's talk about the multi-programming environment. So under multi-programming, what we do, user area of the program is further divided to accommodate the several processes in order to improvise the CPU utilization. So in the first chapter, when I discuss the process management under CPU scheduling algorithm or CPU process scheduling, where we have discussed one of the objective of that, CPU utilization should be maximized. In order to increase or improve the CPU utilization, always some process should be there in a main memory. Always some process should be there. Means user area of the program, we are divided into multiple parts where we can keep multiple programs to improve the CPU utilization. This task of division is carried out dynamically by the operating system, is known as what, multi-programming. So memory management. Memory management, nothing but scattering the memory into multiple parts where several processes you can keep it. The purpose is to improvise the CPU utilization, right? So that I mentioned here. Most modern systems allow to run several processes at the same time, meaning we are keeping more than one program into main memory. So memory consists of large array of bytes, which each with own address. So how to visualize the memory? Simply, it is large array of bytes. So you have to understand memory, you have to visualize as a one-dimensional array of what, bytes or words you can see. Under multi-programming environment, lower side is here, that depends on architecture, lower address side or higher address operating system will reside, and remaining portion we call user area. This user area, please understand, this user area is partitioned, like this user area is there, right? This is a user area is partitioned, like partitioned. This partition to accommodate the processes, let's take process A I kept here, so process B I kept here, process C I kept it like this, so process D I kept like this. So multiple processes you can keep it in the user area of the program. Now, so the division we are doing, the task of this division is carried out by the operating system. There are various mechanisms are there to performing what partition, that will observe now. So I hope you understand.